Large-scale construction projects can be significantly improved in terms of safety, effectiveness, and productivity thanks to cutting-edge construction technology. The ability to develop different types of structures has significantly improved because of the lengthy history of innovation in the construction industry. For instance, the advent of cofferdams and caissons allowed for the construction of magnificent underwater structures. In the meantime, tower crane technology advancements accelerated construction upward, creating the possibility for enormous skyscrapers. Now, we appreciate you coming back again. If you're new here and you like viewing great videos, you should subscribe to this channel because it frequently publishes top-notch material. To make sure you never miss an update after subscribing, be sure to click the bell icon. Now let's begin the video. Number 1. Collaborative software solutions. Due to state-mandated shelter-in-place orders that require many employees to swiftly adjust to working from home, the previous year demonstrated how important it was for construction firms to be able to communicate and share data in real time. In order to effectively communicate information in real time between the office and the field, as well as with other stakeholders like architects, suppliers, building product manufacturers, building inspectors, and subcontractors, the construction industry already had a need for collaborative software. Since decisions in the construction industry frequently need to be made quickly, it is essential to have access to the most recent information in order to prevent expensive rework, keep projects on schedule, and stay under budget. The good news is that this field has already seen widespread industry adoption, and software solutions enable numerous users to collaborate in real time on data updates and task completion. So look for collaborative software to take the lead in 2021 and keeping everyone connected on the same page as we continue to deal with the pandemic. Number 2. Building information, modeling, and digital twins. Better collaboration throughout project design and construction can result from the use of BIM, a method that incorporates digital representations of a building's structural and functional elements. Contractors utilize BIM for prefabrication, takeoff and estimating, planning and scheduling, and clash detection, in addition to as a tool for collaborative design. Due to the 3D modeling and additional data in the models, BIM aids contractors in understanding the scope and design intent of a project. It can also help estimators by creating exact amounts of all building materials and components required on a project for accurate takeoffs and estimates. Additionally, BIM can automate clash identification during the design stage or prior to the start of construction, which can greatly reduce or even eliminate the need for modification orders. A shared BIM model enables changes to be made in real time, allowing updates to be instantly communicated to all project participants, and enabling everyone to work from the most recent information. BIM allows for the simulation of construction schedules, resulting in a visual representation of the construction process that can be used to schedule each stage of the project. BIM is one of those foundational technologies that offer many advantages on its own, and also serves as a base for other construction-related technologies like digital twins, artificial intelligence, and scheduling software. This, together with the ongoing demand for remote collaboration and greater efficiency, could keep BIM adoption high in 2021. With the help of sensors, drones, and IoT, digital twin technology builds a virtual representation of a building from data collected on existing structures as well as those that are still being built. After that, the data is analyzed using machine learning, AI software, and advanced analytics to produce the virtual model and continuously learn from the actual building. This can be used to enhance project scheduling, produce data rich as built, and after the project is finished, be incorporated into building operation systems. Number 3. Artificial intelligence. Similar to BIM, AI is a technology that will be used in conjunction with other technologies to gather the data it will need to learn and make decisions. These other technologies include sensors, wearables, laser scanners, and BIM technology that makes it possible for computers and machines to simulate human intelligence is the focus of artificial intelligence. The most significant advancement in building technology is machine learning, a subset of artificial intelligence which uses algorithms to learn from data, recognize patterns, and make judgments without the need for programming. The enormous amount of data generated by construction projects is fantastic for AI, since it can be utilized to enhance machine learning, predict future project outcomes, help with scheduling, reduce risk, and increase productivity. Finding a method to gather, arrange, and structure all the generated data is the one obstacle standing in the way of fully realizing AI's promise in the construction industry. In terms of applications, AI is being used to keep an eye on employees, spot safety risks or gaps in PPE, and promptly notify the employee and safety manager via smartphone or wearable device so that the problem may be fixed before an accident occurs. The development of autonomous and self-operating construction equipment includes AI as a key component. Now, one area where artificial intelligence can really shine is in the planning and scheduling of construction projects. By simulating the projects millions of times in a matter of minutes and making minor adjustments each time, AI can deliver the ideal schedule that will maximize productivity and efficiency to shorten timelines and save money. Construction drones and robots are powered by AI to track job site activity and deliver timely, useful data to increase productivity. The potential of AI in a building is significant. AI will also be used for forecasting, predictive logistics, risk assessment, and mitigation, in addition to the uses already mentioned. Construction sites will eventually become safer, more effective, and more productive as a result of this. Number 4. Augmented reality and virtual reality. Both augmented reality and virtual reality are new technologies that are being developed and adopted more frequently in the construction sector. In addition to enhancing design, collaboration, and communication, the immersive visualization made available by VR and BIM also enables architects to present their designs to more clients. The majority of virtual reality applications in the construction industry use BIM models as the foundation for the creation of virtual environments that will help eliminate change orders and clash detection before work begins. Virtual reality is assisting business owners in the training and development of the upcoming generation of construction workers in the areas of safety training, equipment operator training, and building systems installation. In a safe environment where different scenarios can be presented while keeping the workers safe as they learn, workers could get exposure to what to expect in the field. Digital things are superimposed over the real environment in augmented reality using markers like QR codes, architectural drawings and photos, or GPS. AR applications in the construction industry use vision-based augmented reality to overlay BIM models, installation instructions, safety checklists, and more to help employees on job sites. The usage of augmented reality in the construction sector is still very much in its infancy, and applications are continually being explored. Construction workers may access information, checklists, or project papers by calling them up on a heads-up display integrated into safety goggles and hard hat visors. This would free up their hands to carry out any other activities. Number 5. Wearables. Wearable technology is being incorporated into personal protection equipment, PPE, and clothing that are already widely used on construction sites, such as hard helmets, gloves, safety vests, and work boots. These wearables for the construction industry will be equipped with biometric and environmental sensors, GPS and position trackers, Wi-Fi, voltage detectors, and other sensors to keep an eye on workers' movements, repetitive motions, posture, and slips and falls. A worker's pulse rate, body temperature, and other vital indicators can be tracked by a wearable packed with biometric sensors, which can also alert safety management right away if a worker appears to be overheating or experiencing overexertion. Now, since the start of the pandemic, the appeal of being able to quickly access this kind of information on employees has increased as project managers and site supervisors seek ways for early detection and screening measures to prevent the spread of the virus and avoid project delays caused by too many workers missing work either because they contracted COVID-19 or because they have to be quarantined due to potential exposure. The use of wearable technology in construction is likely to have the biggest impact on safety, which is always a contentious topic. After all, the construction industry consistently ranks first among all others in the number of worker fatalities each year. A more proactive approach to worker safety can be achieved by being able to track and monitor employees. Watch for wearables to become more widely adopted as construction companies continue to negotiate the challenging waters of completing projects in 2021 during a pandemic. Number 6. Robots and drones. Drones and robotics have assisted automation of building operations, significantly increasing both productivity and safety. In the near future, labor-intensive, simple, repetitive operations like laying bricks, tying rebar, and installing drywall will be carried out by construction robots. Some of the tasks required to set up and launch the robots on the job site will still require the assistance of humans. Most construction robots will support and enhance workers' performance rather than replace them, allowing them to be more productive and maybe extending their careers by minimizing the wear and tear on their bodies that occurs during years of working. Drones for construction are utilized on job sites for a variety of purposes, including site surveying, structure inspection, and site safety. Drones may be used to quickly inspect job sites, track the advancement of projects, and spot potential dangers every day. In order to make sure everyone is working safely, they can also be used to monitor employees throughout the day. Drones, like robots, won't replace the need for humans, but they will require workers to be trained on how to use the technology to carry out these jobs. Drones are equipped with cameras, laser scanners, and other data collection tools that can be applied to increase productivity on the job site using AI. Construction workers that want to minimize the number of employees on the job site during the epidemic will greatly benefit from the ability to do operations with drones remotely. The use of drones in construction should continue to increase in 2021 and beyond due to their numerous advantages and applications. With the introduction of new technologies, the construction sector is continually evolving. Construction companies need to use these new technologies in order to remain competitive. Some of the most significant technologies that will influence the future of construction include robotics and autonomous vehicles. So let us know your thoughts in the comments down below. Please click the bell symbol and subscribe to the channel if you enjoyed the content. Give it to your family and close friends. Until then, you may watch us in the next video below. Goodbye and take care.